So you guys are working on the warm-up. I'm going to throw the answers up here. Would like you to take a look at those. And see what you get. See what you see. So 1, 2, 3, and 5 were all law of sines problems because in each of those you had an angle side pair. Number 4 was a law of cosines problem because you did not. Okay, and that's the way you should kind of sit down and approach those problems, is ask yourself immediately, do I have an angle side pair? If you do, it's law of sines. If you don't, it's law of cosines. Okay, I'm going to scooch it up so that you can see the last one. Zach. Scooch it up just a little bit more to make it easier to see. Did you catch that +2 on number 6? For those of you who didn't, where did my +2 come from? The dude. The dude himself has got the thingy 2 meters tall. Those are our technical terms, the dude and the thingy. The transit. If you ever are driving along a road and you see guys in the orange vests with a tripod type thing surveying the road, that thing is called it's called a transit. And it uses these ideas of trig to map out where utilities are, to calculate what elevation is, to pinpoint exact locations. So those things are very, very useful tools. Okay. So, questions on any of those? Questions are good. Yes. Sure. Do number 6 from scratch. So here we go. Or from the, I assume you meant from the start, right? Okay. All right. So let me start by sketching out our picture. And although the words on number 6 might be unlike anything that we've ever done, we use this general setup quite a lot. We do it when we're finding the height of a tree, finding the height of a pole, all sorts of different things with that. So when I'm looking at the picture, this was 47 degrees. This was 35 degrees. That was 900 meters. And the whole thing was off the ground 2 meters. That whole entire thing across the bottom is raised up 2 meters. And we are looking for the height of the mountain. So what I need to start with is the triangle that I actually have a side length for, which is going to be this triangle right here. So I have to use that triangle first. And so for that triangle, I have that this angle here is 47. So what is this angle right here going to be? 133. Which leaves me with a teeny tiny, what, right there? 12 degrees. So now that I have this setup, I have an angle side pair. Now it's your choice. I'm going to call that A and that B. Since this was your question, David, if you would tell me which one you want me to do, A or B. A. So I'm going to do A. And then I'm going to say, okay, so 900 pairs up with the sine of 12 And I'm going to have A pairing up with a sine of 133. Pens are all dying on me. So let's see here. What am I going to get? So I'm going to take 900 times the sine of 133 divided by the sine of 12. And so I get that piece is 3,165.855. So that's this piece here. So let me kind of re-sketch just what I need so I'm not too distracted. So I know I'm looking for this height here. I know I just found A to be 3,165 point stuff. I know this angle here is 35 degrees. And height is always going to form a right angle. So now that I have that information, which trig ratio would I use to solve this? Angle, this guy and this guy. Sine. So I'm going to say the sine of 35 is opposite over hypotenuse. I know having that h there can get kind of confusing, but that's okay. And then I'm just going to solve this. So I'm going to take that number, times it by the sine of 35. And so I get that the height that I currently have is 1,815.860. But that whole dude has been raised off the ground 2 meters, which is why we do the +2, and you get that. And when you have a word problem, you must have some form of a word in the answer, and meters is my word. Ouch. Yeah, that took a little bit longer, I guess. That's okay. And my goal is always to work smarter, not harder, because I'm kind of lazy. I want to find the easiest way to get there that I can still get it right. And really, it doesn't matter if I'm giving you a triangle on both triangles on the same side, or if I split them up and we did like the helicopter problem. They always work out the same. Because you needed that to build into this triangle. Because if you didn't have that, we wouldn't be able to find either A or B. Any more questions on the warm-up? Yes, sir. Number 3? Sure. So for number 3, we have, let's see here, I'm just going to set it up the way I like to set them up. And ladies and gentlemen, I don't think I saw anybody doing this for the warm-up, but please make sure for your tests and quizzes that you always give me A equals, B equals, C equals, and not just putting it on a picture. Because we need to understand that you can tell which is actually which. All right, so for number 3, we had that C was 25 degrees. I had A was 2, and C was 1. The first thing that you should see with this is that we do, in fact, have an angle side pair. So that tells me to use law of sines. And it's a problem where I only have one angle, so I'm not quite sure what's going to happen with the rest of it. So I'm going to find my height and try to decide how many triangles there are. So my height, angle side pair, so I'm going to take the other one. I'm going to say 2 times the sine of 25, because that's adjacent times the sine of the angle. And when I type that in, 2 sine of 25, get a tiny little piece. Let's do 0.8. So here's my height. This one was my adjacent. This one is my, which one is this? Opposite. So if I compare the height to the opposite, is the opposite bigger than the height? Yes. So we know we have triangles, but I don't know if it's 1 or 2. So then what I'm going to do is I'm going to compare the opposite and the adjacent. Now the opposite is 1, the adjacent is 2. So that means the opposite is less than the adjacent, right? So how many triangles is that? 2. So I'm going to go ahead and I'm going to say, don't forget, I've got another triangle. And I'm going to go ahead and put everything that I know already down there because that's not changing. So far, so good? Then, what is going to be the first thing that we solve for? Can you get the door for me, please? What's the first thing that we solve for? Angle A. So I'm going to go ahead and solve for that first. So I'm going to do, let's see here, 1 over the sine of 25 is 2 over the sine of A. All right, so let's see here. When I go to solve this, I am going to have 2 times the sine of 25 divided by 1, which you really don't need to put, but I'm going to put it there anyway. And then I'm going to do inverse sine of that. Boom. So let's see here. I have 57.697 degrees. We all okay so far? Once you have that first angle, and you know we have 2 triangles, you're going to take that angle there, and you are immediately going to stop and subtract that angle from 180. So I'm going to say 180 minus, grab that sucker. And so for my second triangle, now I have that A is 122.303 degrees. Are you okay with that so far? Once you have that, you're going to handle both of those triangles completely separately. Okay? So with that, how am I going to find my third angle? Absolutely. So I'm going to say 180 minus 25 and that one. So that tells me that angle B in this triangle is 97.303 degrees. Yeah, you need to contact Lewis. Sorry. Okay, and then you would finish using law of sines. And I would do the same thing on this triangle. So I would say 180 minus 25 minus the 122. And I would get 32.697 degrees. And then for each of those, again, working them completely separately, use law of sines to find the missing side. Okay? Nope. That's what's nice about law of cosines, and we're going to talk about why that is with our next unit. But law of cosines, I know if it's an acute angle, I'm actually going to have a positive ratio. And if it's an obtuse angle, then it's going to be negative. So my calculator and you are going to be able to tell what kind of an angle that is. So law of cosines is always just one triangle. Okay. Anybody else in the warm-up? I know it's so irritating. It is that air vent back there. I have asked and asked and asked for them to fix it. He goes, oh, it's just wires rubbing up against each other. I'm like, okay, fix it. It's like I've got a cricket tracked in my classroom, and it's been 3 years. Yes, sir. Okay, let's take a look at number 4. Yeah, that's not annoying at all. What do you think I feel? I've been in this room with it. You know, that's probably a good question. Yeah, I don't think I would recommend that, because what happens if it works the stuff that we need? But yeah, it's really, really annoying. Okay, so A, B, and C. We have side A, side B, and side C. So I have 12, 13, and 5. So for this problem, do I have an angle side pair? No. So that means, what do I have to use in order to solve this? Yeah, this is going to be a law of cosines problem. Now, for law of cosines, I've told you, you always want to solve for what angle first. Law of cosines, you actually want the biggest. Because if I do it for the biggest, the law of cosines is not going to get confused by acute and obtuse angles. So if I start with this right here, I'll be able to switch immediately to law of sines. And I won't have to worry about anything else. It's if you're going to be starting with law of sines that you start with the smallest. Okay? So for law of cosines, if this is the pair that I'm going to use the idea that b squared is a squared plus c squared minus 2ac cosine of b. And you always want to make sure the only place that you see that pair is at the very beginning and the very end. And since I'm looking for this angle, we would solve for that angle. And the way we solved it ended up getting that. Okay, so just walking through and solving it for this, that's what I would have. So I'm going to plug these things in. So I will have 12 squared plus 5 squared minus 13 squared divided by 2 times 12 times 5. And if you don't like the fancy fractions, that's okay. Just put all the top in parentheses. So say 12 squared plus 5 squared minus 13 squared divided by 2 times 12 times 5. That's kind of weird, isn't it? But watch. When I do the inverse cosine of that, it still works. And it should kind of all of a sudden make sense because 5, 12, 13 is one of your Pythagorean triples. So it's actually a right triangle. And then you could switch to law of sines to find anything else you're missing. Okay? All right, let's take a look at your homework, because I know there were some problems with that. I'm psychic, not psychotic. There's a big difference in a few letters. Some people are like going, but are you really? Really? All right, let me guess. Which ones caused you issues? All of them. Well, that's honesty for you. But I have a feeling we're going to talk about 40 and 41. Am I correct with that? No, 41 and 42. Yeah. Okay. You got 41 and 42? Okay, so let's see here. Yes? No. Okay, I know what you're going to ask. In the corners, but that's it. So what you're getting at here, and this is a very important part, which is what we've got on your practice that's coming next. For your baseball diamond, each of these guys are, in fact, right angles. Okay? It's a tipped over square. But what you need to understand is, depending upon if we're talking about professional baseball or little league baseball or high school baseball, the pitcher's mound itself kind of floats closer to and further away from home plate. They set the distance based upon what level you're at. So if I were to draw a line connecting, this is the worksheet problem. This angle here is never going to be a right angle. Okay? Because if it was a right angle, then that means that the pitcher stands right between first base and third base. And if someone throws a ball from first base to third base, it's going to beam the pitcher in the head. So they always offset that. Okay? Now, whether that's going to be in front or behind, you don't know. And that's always going to be your biggest angle, so that's usually going to be a law of sines ambiguous case type of a problem. Okay, where you have to figure out what that's going to be. Okay, so again, I cannot make this clear enough. because it might be on your test or on your review or on something that you're going to see over and over and over again. This is not a right angle. These angles are not going to be 45-degree angles. Don't assume they are. Okay? That's what I'm going to do next. I just knew that that's where he was going with his specific one. This one is a 45-degree angle. Sorry, that is not a 45. I was trying to say it's not isosceles. Okay, thank you. Like, wait a minute. What? Thanks for screwing it all up, Augsburger. All right. Okay. So for our textbook, we had our baseball diamond, which was 90 feet on a side. And we said, where was it? Home plate to the fence in dead center. So I just wanted to make sure that was from all the way from here out was 400 feet. Okay. How far is it from the dead center to third base? So that's what I'm looking for. Okay. What's this piece over here going to be? 90. Now, if this is cutting straight across my square, what is that angle here going to be? 45. Okay, so we got a little bit of a problem. If I just sketch out what I do have, I don't pay attention to anything else. I have 90, I have 45, and I have 400. And I'm looking for this. Will I be using law of sines or law of cosines for that? Cosines, because I don't have an angle side pair. So if I want to kind of think about this in terms of letters, we'll call that A, B, and C just because. And law of cosine says A squared is B squared plus C squared minus 2BC cosine of A. So that means I will say X squared is 400 squared plus 90 squared minus 490 cosine of 45. Running off the page. So that's 400 squared 90 squared minus 2 times 400 times 90 cosine of 45. And then square root that. So 342.328 feet. Because we're in America, baseball is an American sport, feet. And for number 42, it's actually the exact same thing, except for these change. It's not supposed to be degrees, that's supposed to be feet. These change from 90 feet to 60 feet. And this distance here is 280. So 42 is actually the exact same problem, just different numbers. Yes, ma'am. Yes. Just start it. Just start it. I understand. So 29 gives me A is 5, B is 8, C is 9. I flipped it around that time. Oh well, that's okay. Obviously, I don't have an side pair. So we need to do... This is kind of annoying with angles because it's just kind of hard to juggle around a little bit. So we want to do it as few times as we can. So we want to look at the biggest angle because law of cosines will take care of us if it's obtuse. So who is the biggest angle going to be? C. C. So that's what I'm going to set up for. So in setting that up, I have that C squared is A squared plus B squared minus 2AB cosine of C. And if you need to see how we solve that, how we walk through it, the first thing that we did was subtract A squared and B squared. So we'd have c squared minus a squared minus b squared is negative 2ab cosine c, but got to get the cosine c by itself. So we divided by negative 2ab. And in doing that, that's just going to change all of my signs. So I will put the a squared and b squared first. We'll do it like that. And it's I do that because half of the people out there do, half the people out there don't. I know my biggest mistake is with negatives. So basically when I change each of these signs, I put the a and b first, just so that I don't have weird negatives floating around. Trying to keep calculator mistakes to a minimum. And so then all I'm going to do is I'm going to plug these in. So I'm going to say a squared plus b squared minus c squared divided by 2 times a times b. I'm going to do the inverse cosine of that. Let's see? And I'm glad I did that. Oh, I just did cosine. I was like, why did I? Because, yeah, that's like, woo. Take a moment. Look at your answers and make sure they make sense, because that sure as heck didn't make sense. Okay, so I'm going to have 84.201 or 261 degrees. And then you can switch to law of sines to finish it. Yes, because law of cosines, you don't need to worry about adding or subtracting from 180. You just, whatever it gives you, that's your answer. No problem. All right, so we're going to kind of work on 2 separate things today. The first thing that I've got for you, I don't know where I put it. It's under here. Got it. Okay. Okay, so I want you to take a look at my instructions here. I have a very difficult one for you guys to follow. Can you handle this? Put all answers on this sheet, but attach work behind. Does that make sense? That means don't do your work on this sheet, you big buffoons. It's not one of those challenge accepted moments. Okay? So what I want you guys to do is I want you to work through these. I'm going to give you, well, end of the block, I guess, to work through and do these. When you're done, turn it in and grab a review. The review, going to look through this real quick, is broken up exactly like your test. So the first thing that will be on your test is going to be the special right triangles and SOHCAHTOA. The next piece on your test is going to be law of sines and law of cosines, where you can't actually tell the difference between which one it is you're supposed to use. The third piece of your test is going to be word problems. Again, you can't tell which one you're going to use. So you're going to use SOHCAHTOA, law of sines, law of cosines, all of those. And there's lots of word problems for you to practice with that. Then the fourth part of your test is going to be a review, and that review is split up between the last unit that we did and the summer assignment. Yep, that stuff stays part. Your fourth section or last section on every test is always going to be cumulative. So it's whatever came before. So before for us is going to be our transformational graphing, factoring, and piecewise functions, as well as our summer assignment stuff. It's always going to be just that last section has 5 questions from old stuff on it. Okay? Does that make sense? Yes. Yes, you may.